So we're going to do a real quick video on average value. What I'm looking for when I'm trying to find the average value of a function is we're actually trying to find the average y value. So imagine that we've got some function and we're going to look at it from point A to point B. When I find the average value, what I'm going to do is I'm going to find the average y value. If I were to consider all of these y values along this function, what would be the average of all of those y values? So that's what we're actually computing. So let's apply this to something that we're familiar with, and that would be velocity. So let's say that we have some velocity in feet per second and time in seconds. And what I want to do is be able to compute the average velocity. Well, remember that to get velocity, or to get an average, what you would normally do is you would add up all of your numbers. So we'll just say you've got some x sub 1, and we're going to add up all the numbers that we have, and we're going to divide by the number of numbers that we have. Well, if we look at our graph, here's going to be the problem. We have all these velocities at 0, at 1, 2, and all the way out to 6. And I want to find the average velocity, but if I add up just these velocities that I have shown, then what's going to happen is, and then divide by 6, I should say, then what's going to happen is I'm ignoring the velocity from 0 to 1, where this function was increasing through the first second. So somehow I have to take into consideration all of those y values. Well, this actually goes back to what we've done previously when we were working with areas. If I were to find the area of this shape, which is what we've been talking about, think about that in terms of quantities that we're looking at. If I were to find the integral, which would be the area, the integral of velocity, that gives me position. And if you remember when we talked about average velocity before, we said that the average velocity was change in distance or position over change in time. So if I were to integrate velocity, I would get position. So that would give me, if I found the area of all of that, that would give me my position. And then if I divided that by the number of seconds I traveled, which would be 6, that would give me my average velocity. So I've got to kind of apply this to what we've been doing before. Well, remember, how do I find this area? Well, to find area, we do integrals. So if I wanted to find the average velocity, let's go ahead and look at the formula for that. To find my average velocity, what I would do is I would find my integral from A to B. That would be my area. So thinking back to my picture, from 0 to 6, find that area and divide by or multiply by 1 over b minus a, which is also dividing by b minus a. So think of it as this. Now, why would I divide by b minus a? Well, that's going to be the number of, let's make that 0. That's going to be the number of sections that I have here, or the subintervals that I would have from 0 to 6. So in this case, that would be 6 seconds. So remember, 1 over b minus a is the same thing as dividing by b minus a. And that would be where we find our position when I do my integral and divide it by time. And that's how we would get average velocity, which is also how we get average value. So what you've done is when you finish, you will have found the average velocity you were traveling during those first 6 seconds. Now I want to take a minute and look at a geometric interpretation of average value. So let's say we've got this function from A to B, and we calculate the average value, and it turns out to be a number, and let's say that's 3. Okay, so say we went from maybe 1 to 7, and we did our average value, and the answer turned out to be 3. What you just found was that the average y value for this function would be 3. So geometrically, what we're saying is that if you were to draw a line at y equals 3 and look at from 1 to 7, notice how that forms a rectangle, or rectangle. Well, what happens is you found that height of the rectangle, this is your average value. You found the height of the rectangle so that your area would all fit inside that rectangle. So imagine this area would now fill in this area. And that's what average value computes geometrically. Now we're going to take a moment and just work through one problem. Again, remember that my formula for average value is 1 over b minus a, the integral from a to b of f of x dx. So a typical problem might be something like this. Find the average value for f of x is equal to, let's say, 2x plus 7. We'll start with something easy. From x equals 0 to x equals 4. So my formula says I'm going to have 1 over b minus a. Well, my endpoints are my a and my b. So this is a and this is b. So I'm going to have 1 over 4 minus 0, the integral from a to b, 0 to 4, of f of x, which was 2x plus 7, dx. And now we just integrate that. So I've got 1/4. The integral of 2x plus 7 would be x squared plus 7x, but that has to be evaluated at 4 and 0. So I'm going to keep my 1/4 in the front. If I put in 4, 4 squared is 16, plus 7 times 4 would be 28, minus, and then when I put in 0, I get 0. So that part's gone. And now all we got to do is figure out what's 1/4 of 16 plus 28. So if I add 16 and 28, I'm going to get 44. And 1/4 of 44 would be 11. So what we found was if we were to graph this, let me go back up here to the top. Take our formula out and let's kind of look at this thing graphically. So if we were to graph y equals 2x plus 7, so we'll just give it a rough sketch here. We'd start up 7 with a slope of 2, so it looks something like that. Remember, this is at 7. And we considered the part from 0 to 4, that if you were to graph where y equals 11, because that was my average value, so let's say right around there, then what should happen is this area that I have here will fill in this rectangle here. Now I know, or triangle. I know that doesn't look like it would, but my lines are not drawn perfectly to scale, but that's what I just found. That would fill in there, and then the height of that rectangle, which we said was 11, is my average value. So that's all there is to computing average value.